Welcome back, everybody. Okay, today we're talking part 2 of lesson 6.1, the law of sines. Now in part 1, we pretty much showed you everything you need to know about the law of sines. Okay, in part 2, we're going to get into one of the kind of tricky details of this. Okay, this is going to be basically the tough part for the chapter. And honestly, it's probably tougher to explain than it is actually do the problems. But here's kind of the one tricky part about the law of sines. Okay, to talk about that, let's start by going back and looking at some problems we did in part 1. So problem 1, something I didn't really talk about yesterday was this AAS. Okay, as in this is an angle side problem. Meaning that when I gave you angle A, B, and little a, I gave you an angle, followed by an angle, followed by a side. Okay, now if you think back to geometry, we had a theorem that said if I have two triangles and they have angle sides congruent to each other, okay, so two angles followed by a side congruent, we said the triangles have to be congruent, they have to be the same triangles. Okay, the way we're going to look at it is if I'm given angle side of a triangle, I'm going to say that there's only one possible triangle that can be. I can solve that triangle. And obviously, when I have angle side, this is a law of sines problem. Okay, problem 2, the setup we gave you was angle side angle. So as we gave you angle B, C with A in between. So we gave you angle side angle. Okay, again, back in geometry class, we said that if two triangles have angle side angle congruent, we know those triangles are congruent. Here what we're doing is we're saying that if we have a triangle and we're given angle side angle, we can solve that triangle because there's only one other possibility. And again, obviously this is a law of sines question. Okay, let's talk about problem 3. All right, in problem 3, let's take a look. Notice I didn't label it up here. Let's take a look at what we gave you. We gave you an angle and a side and a side. Okay, so we gave you angle B, side A, and side B. Whoops, we don't want to do that. Let's say we gave you side angle. That's better. All right, back in geometry class, you did not have a side angle theorem of congruence. Okay, thank goodness you didn't. Why not? We were still able to solve this triangle with side angle. Okay, there's one little detail as to why you didn't have that, and let me show you what that is right now here. All right, so let me show you what I've got here. I've got a triangle with an angle, we'll say that's fixed, we'll say that's given. Okay, a side of length 6, we'll say that's fixed. And then another side that I'm given, little a, and I'm actually going to be able to adjust this with this slider up top here. Okay, so I'm given angle side. What I want to take a look at is why there's not necessarily always a single triangle. Okay, so essentially we're figuring out what this angle is, and then what this length is going to be. Okay, based on the way I have things set up right now, there's only one possible way for me to make this triangle. Basically make angle B whatever this angle is here, angle C whatever this angle is here, and then this length's going to be fixed. Okay, there's no other ways I could take that angle side and spin things around and connect it for another triangle besides what I have here. Okay, now where this gets tricky is if I make a smaller, like let's say now I have a length of 5 for my A, so again, angle side, there's actually in this case one possible triangle here with whatever length we see here in angle B and C, but there's another obtuse possibility right here. Okay, so based on the angle side I gave you here, there's two possible triangles, and that's the whole reason you didn't have the side angle theorem back in geometry classes, because in some cases there's two possibilities. Okay, where this gets even trickier is if I make A smaller. Notice if A gets too small, there's no possible triangles. I can't make this line ever connect down here based on this angle side and side length I'm given here. Okay, so what are the rules? Well, let's kind of show you a circle here, centered at C. Okay, basically, as long as my A, my side opposite my angle, is greater than the adjacent side, there's only one possible triangle. Okay, as you can see with this circle with the radius centered at C, radius of length A I have here, I can't connect anywhere. But as A shrinks, and when A gets smaller than the adjacent side, okay, so when my opposite side of the angle is smaller than the adjacent side, that's where I have the two different possibilities. Okay, when will that triangle disappear completely? I'm going to show you the height of this triangle based on the base on the bottom here. Once my A gets shorter than that height, okay, that's when I no longer have a possible triangle. Okay, so let's kind of show you that stuff again. Okay, so again, as long as the opposite side is longer than the adjacent side of that angle, there's only one possibility. If it is shorter than the adjacent side, but still longer than the height, that's when I have my two different possibilities. And when the A gets shorter than the height, that's when I have no triangles here. Okay, so let's go to the way we have that laid out for you in the notes. Okay, when we have the side-side angle for a triangle, there is one triangle when the side opposite the angle is greater than the adjacent side, two triangles when the side opposite the angle is less than the adjacent side and still greater than the height, and then we'll say zero triangles when the opposite side is less than the height of the triangle. And if you prefer more of a visual kind of definition there, again, here's my angle, side, side. We have the opposite side of the angle, the adjacent side of the angle. It's one triangle when opposite's greater than or equal to adjacent. Two triangles when the opposite's between the height and the adjacent side, and zero triangles when the opposite is less than the height. So going back to problem 3, part A once again, we already did a side-side angle question. And I'm going to say we didn't need to worry about the ambiguous case with this one, because notice we've got our angle B, the opposite side is greater than the adjacent side, so that's the case where we have a single triangle. Okay, so we ignored the ambiguous idea. We still did this problem anyways. We still got the right answer. There's one possibility. What I want to get into for the rest of this lesson is taking a look at how do we deal with the two triangle possibility. All right, so let's take a look at how to deal with the two triangle case. Right off the bat, I'm just going to split my work area in two. Okay, the toughest part about this for me is it's going to be hard to fit everything in this screen. Okay, in a classroom, I'd have an entire whiteboard I'd be filling up with this problem. Okay, so bear with me with this one. Let's take a look at what we've got. We've got triangle ABC once again. And we're given angle B is 38 degrees. We're given little b is 21, and C is 25. Okay, so I have my angle side-side or side-side angle where the opposite side is shorter than the adjacent side. Okay, so that means that this is the ambiguous case. Now, as far as could it be no triangles, yes. I'm going to say I don't need to worry about that here though, just because 21 and 25 are pretty close in size. I'm pretty confident that that 21 is going to be greater than the height to kind of this other side I don't know's base. Now what I could do is calculate that here real quick, figure out what this length is. For that, I'm going to use this right triangle kind of in the bottom corner. I've got the opposite side, I've got the hypotenuse of that triangle. The height is the opposite side. So I could set up that sine of 38 is equal to opposite h over hypotenuse 25. And multiply both sides by 25 to give me h is equal to 25 sine 38. And when I plug that all in, I end up with a 15.4. Okay, so the opposite side is shorter than the adjacent side, but still longer than the height. So I know I'm going to have two triangles. This isn't a no triangle possibility. Okay, so again, I probably didn't need to check that just because those lengths are pretty close to each other. if that side length B was like a 7 or something. Okay, I can probably tell that's too short. All right, but I didn't really need to check there. Okay, so let's start solving here. And what can I solve for first? Well, the first thing I can find is this angle C, kind of like we did in the last lesson. I know both the B's. I know one of the two C's. So when I go to plug things into my law of sines, I'm going to put the C on the left just to make it look nicer. We could say we have sine of big C over little c 25 is equal to the sine of 38 over little b 21. Okay, and we want to get this c by itself. So first we'll get rid of the 25. So I'm going to multiply both sides by 25 here. And that will give me sine of c over 25 is equal to, we can say 25 sine 38 over 21. Whoops, and we got rid of the 25. Wake up. Wake up. And then to get the c by itself, we're going to take the sine inverse of both sides of the equation. I'm not going to write that here and show the crossing off. I'm just going to say that I know c is equal to the sine inverse of 25 sine 38 over 21. Okay, when I plug that in, I get a 47.133, rounding to 3 decimal places. All right, so there's my angle C. That is the big C in degrees. Make sure we don't confuse that with a little c. Okay, next up, once I know two of my angles, I can find angle A. So let's do that. I'm going to kind of wall things off here. I know that angle A is just going to be equal to 180 minus the 38 we were given, minus the 47.133. All right, so angle A is going to be 94.867. And then the last thing we can find is the little a, side length A. And for that, I'm going to go sine of A over A. So in other words, we can say sine of 94.867 over the little a we don't know is equal to, and I'm going to use the b's because they're both giving me right away nicer numbers. We can say sine of b, so 38, over little b, 21. Okay, cross multiply, divide. That's going to leave us a is equal to 21 sine of 94.867 over sine 38. And when I plug that in, I get a 33.987. All right, so there's my big A, little a, and big C from the first possible triangle. And really, that's nothing different from what we did yesterday. Here's the new part. Here's the tricky part. We've got to figure out first off, what that new triangle is going to look like. So here's how I'd recommend visualizing this. I'm going to make a dotted triangle and set it up the same way I started off with my original triangle, where we have, so A, B, C. B's 38 degrees. Okay, little b is 21. And little c is 25. Okay, now those measurements are fixed. Those aren't going to change. So what I'm going to do is I'm going to undot the angle B. That's not going to change. That's not going to get any bigger and smaller. That's fixed. Same thing with side length C. That can't get any smaller. And side length little b, it is what it is. This is going to be the same size. Okay, what can change here? Which of the sides can get smaller as my angles get bigger? Well, that's going to be this side A. Basically, what's going to happen is this is the side that can swing in. Okay, I can't swing this side length together. I can't swing this side length together. Okay, but I can swing these two angles closer together, shrinking this size, and that's what's going to happen here. This length is going to swing, leaving me with my obtuse triangle here, still with a length of 21. Throw another arrow on it just to show you how that's kind of swinging there. Okay, so this is the new triangle I want to solve, where we'll say now we have the original b, original little c, but now we want to know what a prime is, angle c prime is, and side length little a prime. How are we going to do that? Well, in our first triangle, we started solving for c first. I'm going to solve for c prime first on this second triangle. And I'm not going to use any trig. I'm just going to use some basic geometry. Here's the trick for figuring out c prime. Notice if I look at this triangle made up of the two side lengths of 21, kind of the smaller triangle here, what do I have? I have an isosceles triangle. Triangle with two side lengths the same length. Isosceles triangles have the sides opposite those congruent lengths. Sorry, the angles opposite those congruent lengths congruent as well. So meaning this original C I found here of 47.133 is going to be the same as this angle here. This will also be a 47.133. Okay, so these two angles are congruent, and I know what that angle is. Okay, the new C I'm interested in right here is just the supplement of that 47.133. Suppose I'm going to make that blue here. That's the angle I want to find. So to find that, what we'll do is we'll say that C prime is equal to 180 minus the 47.133. Okay, because again, we have a linear pair here. I can tell that from my straight line. And that's going to give me a 132.867. We'll say degrees. There is my new C for my second triangle. Okay, once we have both angles, we can figure out this A prime then. Well, that's just 180 minus the two angles we have. Okay, so big A prime is going to be equal to 180 minus the 38 we're given initially, minus the 132.867. When I do those calculations, I get a 9.133 degrees. Okay, so there's my adjusted angle. This angle got bigger, therefore the other angle had to get smaller. And then we'll finish it off by finding the little a prime the same way we did over here, just using that new angle A. So again, I can say sine of 38 over 21. Okay, that's the original B's I was given. Those haven't changed. Is equal to the sine of the new A over little a prime, we'll say. Cross multiply, divide, that's going to give me that a prime is equal to 21 sine of 9.133 over sine 38. Therefore, little a prime is equal to, when I plug all that in, a 5.414. All right, there we go. So again, there's two possible triangles here based on these lengths. Here are my 1, 2, 3 missing sides and angles from the first possibility. Then I have 1, 2, 3 for the second possibility. Okay, test and quiz time. We'll have the answer blanks all filled up for you to fill in. Okay, you'll do your work and then put them in the answer blanks. You'll see how that works. Okay, but there's an example of the ambiguous case, finding two triangles. Okay, it's a lot of work, a lot going on. It's kind of rough the first time through. It gets better as you go through more of these. Problem B is the same idea. Why don't you take a minute, pause the video, work through problem B, and then hit play to either get unstuck if you're stuck or just check your answer if you get all the way through it. Alright, so let's run through part B here. Got two sides of my workspace for two triangles. We'll start off with kind of the regular triangle ABC. We're given angle B again, 43 degrees. And this time we're given angle A is 7. I'm sorry, side length little a is 7 and side length little b is 6. Okay, so we have angle side side, and once again the opposite side is shorter than the adjacent side. So that's why we have two possibilities. And since these are so close together, I'm not going to bother checking the height. That'll be our last example to show you one that doesn't work. Okay, first thing I can solve for here is going to be my angle A. Okay, I can get the, since I have the side across from it, I can solve for that. So I'm going to say we have sine of big A, which we don't know, over 7, is equal to sine of 43, which is big B, over little b 6. Okay, I'm going to jump right to what I'm plugging in my calculator here. I'm going to say A is equal to the sine inverse, because I'm solving for an angle. And then if I look up here, I need to move this 7 up by multiplying, so it's just going to be 7 sine 43 over 6. If you need to pause the video and work from this step to this step, more slowly on your own, that's fine. Okay, but I'm just going to jump right to what I'm plugging into the calculator. When I plug that in, I get a 52.718 degrees, all right, for my big A. Now I'm going to star that because that is what I'm going to use to move over to my second triangle, that first measurement. Okay, we've got big A, big B. We can find big C now. We can say that angle C is equal to 180 minus the other two angles. So minus 43 minus 52.718. When I do that, I get an 84.282. And last thing I'd find is the little c. Okay, using the angle C we know now, we can say that sine of the C we just found, 84.282 over little c, is equal to, we'll use the b's because those are nicer numbers. We'll say sine of 43 over 6. Okay, cross multiply divide is going to leave me with c is equal to 6 sine 84.282 over sine of 43. Okay, when I plug that in, I get an 8.754, we could say. Alright, so there's my big A, big C, and little c, okay, for the first possible triangle. Alright, so halfway there, we just got to do the second triangle now. Biggest part of this is figuring out what the triangle is going to look like. So once again, I'm going to make a dashed kind of original triangle here. Triangle A, B, C. I'm going to fill in what the problem gives us for this triangle. Okay, B is still 43 degrees. Little a is still 7, and little b is still 6. Now for that second triangle, that's what I'm given. Those measurements aren't going to change. Okay, so I'm going to kind of make those fixed lengths and fixed angle measures. Okay, what can change here? Well, the side length of 6 and 7 have to stay 6 and 7. The side length that's going to shrink and get smaller is going to be the side length C. We can think of this length of 6 swinging in to make that obtuse triangle. So I'm going to say that this is length 6. My triangle swung here. And then what I'm looking for then is the A prime, this larger angle. Okay, the C prime, and then we'll also want the little c prime here. Okay, remember how to get going on this skinny triangle is these two angles are still going to be the same. There's still going to be this original A we found here, this 52.718. So to find this angle A prime then, right here, we'll just take 180 minus that 52.718, and that'll give us its supplement. Okay, so A prime will be 180 minus the original A, 52.718. And that gives me a 127.282. Again, since I found A first on the first triangle, I'm going to find A prime first on the second triangle. Okay, from there I can find the C prime, big C prime. That's just going to be subtracting the other two angles from 180. So 180 minus the original 43 minus the 127.282, which gives us A 9.718 degrees. Okay, because once again, the angle A got bigger, therefore C has to get smaller. And then to finish things off, we'll find the little c prime here. And we'll set that up as sine of c, the new 9.718, over little c prime is equal to, we'll go back to the b's, the 43 over 6, which we used in the first problem twice. Now we're using here. And when I cross multiply divide, that's going to give me c prime 6 is equal to 6 sine of 9.718, all right, over sine 43. All right, in other words, a 1.485, which makes sense because that side shrunk. Okay, so we'd expect it to be a lot smaller than the original C. All right, so there are our A prime, C prime, C prime for the second possibility. All right, let's take a look at one more thing quick. I want to show you the case where there's no possible triangles. Okay, this will be fast because there's no answer. So let's set this up. ABC, I'm given C is 38 degrees. I'm given little b is 9, little c is 5. Okay, so I have angle side side where the opposite side of the angle is shorter than the adjacent side. Okay, so I know this could be two triangles or no triangles. Now the reason it looks like it's probably no triangles is notice the opposite side's a lot shorter than the adjacent side. Okay, it's almost half the size. So that tells me that I should probably check and see is this opposite side shorter than what this height would be? For that, we'll look at this right triangle. We can say that sine 38 is equal to opposite h over hypotenuse 9. Multiply both sides by 9, we get h is equal to 9 sine 38. And when I plug that in my calculator, I get a 5.5. Okay, so this height is longer than the opposite side. That's how I know this one is no solution. Okay, now, nice part about this one is if a triangle doesn't work, I won't be able to get going with it. Let's say I tried to solve for angle B here and set up sine of big B over 9 is equal to sine 38 over 5. Okay, what will that be equal to? Big B would be equal to the sine inverse of 9 sine 38 over 5. And get out of here. When I go to plug that into my calculator, what happens? Domain error. Okay, values entered is not allowed in the function or command of the sine inverse. Did I do sine inverse? Yep, we did sine inverse. Okay, so in other words, sine inverse doesn't work for this impossible triangle. It won't even let you get going with it. All right, there you go. There is the ambiguous case. Okay, that's the hard part of this chapter for the most part. And really, when it comes down to it, it's only one test point, so you'll get it. I mean, it took us a while to get through, but as you go through a few of these, it gets easier. Okay, so finish up the homework for the law of sines. Once you've done a few of these ambiguous problems, the rest of it is easy, no sweat. Okay, so finish up the homework. Let us know if you have trouble. We'll be here to help you out.